In this video, we're going to talk about the different operations that you can do when you have radicals. So the first example we're going to talk about is 5 radical 2 plus 3 radical 2 minus 2 radical 2. So we're going to talk about adding and subtracting radicals. Now, how I want you to think about this question, so I want you to think about those radical 2's as x's, and how would you solve 5x plus 3x minus 2x, or how would you simplify that? Well, you would just go through your basic order of operations and combining like terms. So we take the 5x and the 3x and put it together, which would make 8x, and then subtract 2x, and we would get 6x. Well, when you have radicals, it's the exact same thing. When you have a radical with the same number under each of them, so in this example, all of them have radical 2 under them, we can combine these just like we would as if they were like terms with x's. So this answer is going to follow the exact same process. 5 radical 2 plus 3 radical 2 is 8 radical 2, and then minus 2 radical 2 is going to be 6 radical 2. So that would be our final answer for simplifying this expression. Now, what happens when the radicals are not the same? So, for example, in this second one here, these radicals are not the same. And I'm actually going to ask you to do me a favor. I made a small mistake. This should be square root of 18 plus 2 radical 2, not 2 radical 27. All right. So what you want to do when they're not the same, so when these things are not the same, you must simplify first. So we're going to have to simplify these radicals first before we could see if we can put them together. So we know square root of 2 can't be simplified, so we're going to leave that one alone. But square root of 18, as we talked about in a previous video, we can take the square root of 18 and we can break that down and make it simpler. So I'm going to take the square root of 18 and I'm going to break it down into square root of 9 and square root of 2. Now I know the square root of 9 is a perfect square, which is 3. So I can take this and rewrite it as 3 radical 2. So instead of 18, I have 3 radical 2 instead. Now, with 3 radical 2 instead, I now have, as we spoke about in the beginning, the exact same radicals. Now I can treat this as if they're like terms, and I can put 3 radical 2 and 2 radical 2 together to get 5 radical 2. All right? So the summary of this, or just the basic idea, is if you have the exact same radicals, you can combine them together just as we would like terms with x's and y's and other variables. If they are not the same, and they are not like terms, or not the same radical, you have to try to simplify them down as much as possible, and then see if you can simplify. If we would have gotten to this point and these two radicals were not the same, then we would just leave it alone. We wouldn't actually simplify any further. All right, so that's it for adding and subtracting. The next operation that we're going to deal with is multiplying and dividing. We're really only going to cover multiplying here. So multiplying radicals is kind of 2 steps. Okay, you multiply everything on the outside. So we're going to multiply the outside, which in our first example there is no outside, and then we're going to multiply the inside numbers, and then the last step is we're going to simplify if possible. So, for example, we have square root of 10, square root of 2. Now, these can't be simplified when they're separate like this. But after we multiply them together, and our first step is the numbers on the outside, which is really just a 1 and a 1. We're not going to have anything different on the outside. And then we multiply what's on the inside. So we would get square root of 20. Now, after we do the inside, we now have to try to simplify. So with square root of 20, we can try to find a perfect square that goes into 20 by listing out its factors. All right, so try to think of a perfect square that goes into 20. A perfect square that goes into 20 is 4, and 4 times 5 is 20. So now the perfect square of 4, square root of 4, is 2. And square root of 5 cannot be broken down, so we put these two together, and we get our final answer as 2 radical 5. All right. Now, we're going to do one more example like this just so we can go through the process a little bit differently, or the full process. So 2 radical 15 times 4 radical 3. So our first step is to multiply the numbers on the outside. 2 times 4 is going to be 8. All right, then we're going to multiply the numbers on the inside, 15 and 3, and that's going to be square root of 45. Now, we haven't talked about this, is what happens when the numbers on the outside of the radical is this is multiplication between this 8 and square root of 45. So what we're going to do is we're going to take that 8 and save it for later, and we're going to multiply it at the end. All right, but next, now what we want to do, our third step or our final step is to simplify. So what we want to do is we want to take the square root of 45 and break it down. All right, we want to break it down into a perfect square and a non-perfect square. So try to think of a perfect square that goes into 45. Perfect square that goes into 45 is 9, and then 9 times 5 is 45. I know that 9 is a perfect square, so it comes out as a 3, and then the square root of 5 can't be broken down, so our simplification here is 3 radical 5. Now I got to take that and put that back into this equation, and now I have 8 times 3 radical 5, and just as we said before, we can multiply what's on the outside. So 8 times 3 is 24, and the radical 5 stays the same. All right, so multiplying can be done the same way. We can think of our 3 steps here. First, multiply the outside numbers, multiply the inside numbers, and then simplify as much as possible. So we're going to be using simplifying radicals, we're going to be using adding and subtracting, and multiplying to kind of solve problems and get our final answer.